Okay, we are going to create a groom on this character. We have some poly hair that it's done for the animation department so they can have a good silhouette to decide the poses. And we are using just this hair to create the groom. We are using hair tubes. Those are hollow, they have no caps, no start or end caps, and they have the UV mapping in this square layout, normalized from 0 to 1 on both axes. This will allow us to create some UV transferring to recreate the position from all this geometry into the new hair strand system. These are going to be named blocks, and we are going to use some loops to iterate on them and create the hair strands. And then on each strand we are going to do the individual hairs, the individual hair curves that are going to be rendered out. So let's start this. We are going to use 3 different grooms. This is the original character's groom with some curly hair. We are going to do this straight hair, and we are going to do this mohawk, just to show the adaptability from this system. I'm going to hide this, and let's start with the curly hair. Alright, we are going to start off by doing some geometry that we will transfer onto the UVs of the hair blocks. I'm going to create a circle, and on this circle we need to have the UVs on a straight line starting from 0 and finishing on 1. So we are going to treat this circle as a open curve. We are going to use the polygon and open arc mode. This way we are going to have just a line that it's going to go from the point 0 to point 12, and we are going to create some UVs from this circle. We are going to do a UV texture node, and we are going to use the uniform spline mode to create the UVs. Let's check this on our UV viewport, and here we are from 0 to 12 on our circle. We can change the divisions on this circle, and we are going to have the same result. We are going to fuse now the circle because we don't want to have 2 points here, one on another. So let's do another circle. And we are going to have the same number of divisions, 13 divisions. And we are going to do some attribute transferring to recreate the straight UVs on this circle coming from this one. We are just going to fuse that point over there. We are going to keep our UVs on a straight line, but we are going to be able to project these UVs onto these circles using an attribute transfer, attribute copy, and we are to copy from this geometry, and using this geometry we are going to copy from the vertices the UV attribute. So here we go. Okay, now we have the straight lines UVs, and I'm going to create a new UV texture node. Plug it here. And now I'm going to do an orthographic projection on our Z-axis because we need the UV values on a flattened out mode so we can scatter based on the UV position. But I don't want to lose the UV on a straight line that I did here, so I'm going to save this UV attribute as UVW so that I don't lose the data. Alright then. Now let's iterate on the geometry. Okay, let's do a loop. For each connected piece, we are going to iterate. Let's keep it just on a single pass. This curl would be nice to work on. So we are going to change the name here from class. We are going to rename it to block. Just to keep a consistent naming on everything. And then let's create a UV transfer. Let's plug this one here and this one here. And now we must use an UV attribute on a vertex class, and we are going to transfer to our points the point attribute that it's from this geometry. Let's change the position attribute. So we got now a nice representation of the original curve, but with this slice of geometry. Now with our for each loop, we are going to repeat this process on every hair block. That's nice. Let's create a slice for every position of the hair. Well, let's create the slices. Each slice will create a representation on the cylinder that creates the hair block. And the easiest way to change the position from this slice onto the hair tube is to change the UV attribute from this line. Right, we are going to check our UV viewport. The first hair slice that we are doing has the UV on 0 to 1 on the U axis, but the V axis will allow us to move the position of the slice along the UV tube. Then if we just change with a wrangle here the UV position, we are going to be able to translate this slice onto the tube. We just don't want to do that right now, but let's start off by doing some modification to the system. We are going to use a copy node. we are going to create some copies of this circle and translate it on the z-axis. So for every copy that we do here, we are going to create a copy. So we can do this fully procedural. We have to subtract here a value so that we always have a position from 0 to 1. No matter how much copies we are doing, we will have always the same values from 0 to 1. This will be very useful because we want these UV lines from the UV attribute to be translated to into the vertical value according to the distance that they are on the geometry. The easiest way to do this is using a attribute wrangle. We are going to pass it on vertices. Using the y vector from the UV attribute, we are going to pass the position on the z-axis. So here we go, we have the geometry, the UVs on the u-axis now, and the p-axis now. So this way, when I'm transferring the attributes onto the hair block, every slice is covering just a little part of our hair block. I'm going to change the color from this copy node so I can identify that this is a control node. And no matter how much copies I'm doing here, every slice is going to be on the correct position. We can increase the quality of the system by increasing the number of slices and the number of divisions that we are doing here. We can also create a quick iteration from the groom, creating a low number of divisions on the slices and on the radial divisions from the circle. Okay, let's scatter some points on these slices. I'm going to change the UV view to represent the UVW attribute, just so we can visualize the correct texture space on the slices. Let's create a scatter node. We cannot just scatter on each slice this way, because we need to have some consistency between the number of points that are scattered on the first slice onto every other slice. So there's also some issues on the surface On the places where the geometry is a little stretched out, so let's create a nested loop. We are going to create another loop with a primitive parameter. There's an error. Right, for each primitive we are going to loop. Let's just concentrate on the first slice. We are going to create a scatter node, plug it here, and there's the issues with the geometry. When the geometry is stretched out, the scatter will not do a good job. That's why we had the UVW attribute to change this to a texture space and scatter on the UVW attribute. So we get some nice points here. Let's lower a bit the relax iterations because we are going to do a lot of iterations here. We don't want to have a really slow process. And this is important. On our output attributes, we are going to create an ID attribute. This ID attribute will allow us to connect each point from each slice to the next point of the slice. So let's iterate on each pass, and we have a consistent number of points on each slice, and every one of these points has the same ID attribute. Now we can use those ID attributes to create a curve using an add node. We are going to use the polygon mode, we are going to create by group, and we are going to use the by attribute option here and use the ID to create a curve connecting every instance of the same ID along every slice that we have there. So let's look how our iterations are doing. And here we go. We have every geometry block converted into guide curves or hair tubes. Let's change the style of the grooming, and this is working really fine right now. We got some nice guide curves. We can change the color here. This way I can tell that this is a control, and we can change the density attribute to control the number of guides. We can also change the number or the relaxation from these guides. No matter which kind of geometry we are inputting to the system, these will consistently create guides for grooming. Just having the proper UV attribute on the hair tubes. Right, let's give some more lines here. For straight hair, we could just finish this and start with the hair tubes. But for this curly hair, I just love to have some twisting from the base of the hair block onto the tip of the hair block. So let's start with some slanting on our UVs. Let's rename this first of all, and create a new wrangle. Let's call this wrangle slant UVs. Run it onto vertices. Let's check out our UVs. So let's use the Y position on the UV vector to modify the X position for our UVW value. So let's create a ramp. Let's call this ramp slant and use as a parameter the vector UV on our Y axis. Create a ramp there and add this to the UVX component. Let's just add this. And there we go. We got some nice slanting right here. We could just control this with this ramp. In this way we can have some nice straight hair or just use the twisted hair here. We might run with some issues if we have the UVs on out of the UV 0 to 1 space. So just let's be sure that all the values that are going further than 1 will be repeated right here. So let's just create a modulus. Let's take the vector UVX and let's assign it to the UVX modulus 1. This way, no matter how much we change this, all the UVs will get mirrored on our x-axis. This is really useful for tiling purposes. Let's just check how this is working on the 3D space. There we go. We have some nice twist on our strand, and we can control this by changing this ramp. Let's try now and create some multiplier for this slant, and let's create the global multiplier so that we can control not just the twist from the base to the end, but we can control the twist overall. It's looking really nice right now. Let's just check this. And there we go, some nice curly hair for our character. Let's create some values for each individual curved tube. Let's create some individual values for the hair tubes so we can control the width of each one of them. And let's also assign some values that will be useful further on when we are shading. We are going to create a block value, a tube value, so we could randomize each one of these strands, and we are going to create a width value for these strands. Okay, let's start getting some attributes on these curves to convert them into tubes. First of all, we are going to create a UV texture node to create UV values on the curves. Let's create them on the points and assign them as an uniform spline. We can look at them here on our viewport, coming from 0 to 1 on the UV space. We can use this data to drive some interesting attributes like the width of each hair, the color. Let's just visualize this. Let's get this on UV data. And our max should be 1. Okay, here we are. The base of the hair is one color and it travels onto the tip of the hair with another color. And let's then create a way to control this attribute from the length of the curves. Let's create a attribute wrangle running from points, and let's use a ramp. Let's call this ramp scale and create a ramp called ramp scale, and it will be driven by the UV X value. Right, let's create the nodes, and now we have to create a p-scale attribute, the point scale, and assign the ramp that we just done. This way we can create a polywire just to get a look at how this will be behaving. The wire radius, let's set this at 1 and assign an attribute. By default it's the point scale, and we can see that the scale is backwards. Let's create a global multiplier to control the overall width of our hairs. And let's just invert this ramp. I don't like to change the direction of the points, so let's just give it a 1 minus the current value. So here we are, we got some nice hair going on. This will be a little slow because we are doing this via polywire, and this is just a lot of geometry. We shouldn't be doing hairs using polywires. This will just take too long to calculate and too long to render. So let's use instead a shading method for the viewport. We are going to use an attribute called width. Let's assign this to the p-scale. And now let's just tell Houdini that we want to use the advanced shading on our curves. Let's go to our geometry container, and on the miscellaneous tab we can turn on the shade open curves in viewport. This way we can get a shaded visualization of the curves, taking the width that we are inputting to the curve value as the width of the curve. This is really useful to get a previs for the hair. Right, let's compare this to the polywire. When doing the open curve shading, sometimes it gets a little funky. The polywire gets black, so we might have to be switching. Oh yeah, here we have it. All right. So the width of the polywire, it's not quite the size of the shaded tubes. Let's just give it the double of the width and compare it to the polywire. Now we have almost the same size. Okay, and something really good about this curve shading is that all the visualizations work really nice with this. All right, let's continue. The next step is creating a group of curves on each hair tube to send out to the render engine. Before this, I'm going to trim some of the hair. We have too much hair coming onto the tip of the hair block, so I'll just drop a guide process node. As this guide process just needs some curves to be inputted to the first one of the inputs, we can use the guide processing tools that are here on Houdini to modify this system. Let's just change it from set direction to set length, and we are going to scale let's just multiply the scale. This way we can modify the groom in a procedural way. And let's just randomize this with a minimum scale factor and max scale factor. Let's just do everything else. And then we have some strands that will be a little bit smaller than the others. We can get a lot of control in this way. Okay, now for the hair points on for each tube, let's create a new now we have to create the points that are going to be converted into lines for each one of the tubes. We could iterate over each curve, but I don't know if that's a really good idea. There's a simpler way to do this, and it's just doing a copy to points. Let's create just a cube and a copy to points. Right. I'm going to disable the shading of the viewport, and all these curves are being copied to each one of the points of the strands. We have to do some orientation attributes. Right now our curves are a bit are not oriented to anything, And we have to modify the curves. The smaller curves have too much geometry right now, and the long curves have almost no geometry. So now, to preserve the detail, I'm going to create a resample, just to be sure that everything has the same amount of geometry. We could even define how much quality do we need for the system with the length of this resample. I'm going to change this color so I can know that this node is controlling something. Okay, now let's create an orientation attribute. I really like to get some color on the test cubes that I'm using. Let's create color on our primitives. Let's just use the front, then the side, and the top. This way I can know always how the orientation for my geometry is going. Here we are, all the cubes are oriented to the same place. Now, when working with cubes, we just don't tend to think about them as geometry. The cubes just have a point position right now, but they can have UV values, as we have been using them right now to create the shading. They also can have normal data on them, or a tangent or a bitangent data on them. To create this data, we need to use a polyframe node, and we can create a normal and a tangent onto the points. Let's take a look at those attributes. Let's change our visualizer to a marker of a vector, and let's change this to tangent on the U direction. Here it is. Let's hide our geometry, and let's take a look at just one hair. Here it is. Our vector is pointing right to the direction that our curve is facing every time. So this will be really useful when setting up the orientation value. Right now, using the polyframe, creating a normal attribute, the cubes that we are scattering onto the points are getting some sort of orientation, but it's a little bit wrongly done. These cubes are facing to another side. The cubes are not quite facing the right direction. So let's create a new orient attribute from scratch. Right, I'll create an attribute wrangle, and let's call this create orient attribute. Alright, let's create this orientation from scratch. We need two vectors to create a transformation matrix. The first vector that we are using is just the tangent u value that we just calculated, and we have to feed a secondary vector to the system. On a more complex setup, we could copy the normal from the geometry to each one of the hair strands. That will be the best way to do this, but for the sake of simplicity, I'm just creating a reference vector. I'm going to create a vector named up, and we are going to set this value to 0, 1, and 0. This vector will be less likely to be in conflict with the hair facing just up. And then we have to create a matrix. And I'm going to call this matrix transform. Let's use a make transform function. We need to feed it just two vectors, and let's feed the vector tangent u and the vector up. Okay, and now let's create the orient value. Let's use p orient. This will equal to our transform. The orient value it's on a quaternion mode, so we need to convert this matrix into a quaternion to feed it to this orient value. So let's use a quaternion function and use this transform. Right, here we go. So now everything looks a lot better. The cubes are all facing the right direction, except that they are going backwards. Our vector for the tangent u position, it's not facing the right direction. Let's just negate it, and there it is. There's just a little error here, matrix 3. We have to use just an orientation matrix. So here we are with our nicely oriented cubes. Let's just switch from one to another, and there we go. Let's now create some points to scatter onto the system and convert them into lines. We are going to do something really similar to the main loop for the hair tubes using an add node. We are going to use an ID attribute. So let's create this beforehand. This copy to points is just a visualization. We are not going to really need these cubes. Let's start off by let's create an ID attribute. We can run this from primitives, or we can run it just from points. Right, let's create ID attribute. And for every point we have here, we want it to reference to the primitive that we are using from the point. So let's just create an integer value called hair ID, and this will be the integer primnum. Right, let's visualize this attribute. Let's get hair ID and randomize. Okay, it's not working right now. Right, let's check this attribute so we know that everything is working fine. I'm creating a visualize attribute, and let's use the random attribute with the hair ID attribute. So this is working just fine. Each one of these hairs has a slightly different color. So we got here the cubes, and let's create some geometry that will represent the hairs inside the hair tube. So we know right now that this axis is going to face forward to the direction of the hair. And let's create just a circle. We got to be sure that the radius of this circle is just similar to the box width and height. And let's just scatter some points here. We don't want to have too much points in here because we are going to scatter these points on each one of the primitives of the hairs and on every hair tube. So that will be a lot of geometry really fast. And we have to do an ID attribute. Let's create an attribute wrangle. And slice ID for this name, and we are just feeding the point number on these points. So we're going to copy the points right now, and here we go. Each one of these points now is scattered onto the surface onto each point of the groom. Let's create an add node, and if we create geometry right now, this will be chaotic. We have to fit this adds up an attribute, a properly done attribute. Let's create this with a wrangle. Let's create, let's call it line ID. And let's start off by creating a randomized attribute from the hair ID attribute that we created here. So let's create a random function using the hair ID. There's just a warning. Okay, we have to tell this explicitly that we want this result on a integer value. So this way we can have this hair ID attribute to drive the randomness here of the strands, but we got to multiply this by a really big number. We don't know how many points we are going to have on each strand, but we have to have a unique ID attribute for every set of points that we are scattering here. So let's just be sure with a really big number, And then we are going to add this to the value of slice ID. Right, then I'm just going to use the line ID attribute, and here we go. We are getting some nice individual hair strands on each tube. Let's randomize these primitives just to take a look on how our groom is coming right now. So it's looking really, really nice. Let's just play around with this. This scatter node will be important because it will tell our system how many hairs are we going to use. So let's change this color so we can tell that there's something being controlled here. And let's change our hair width. Let's change this color also, because we need this to define how much the hairs are going to, the hair clumps are going to extend. Right now it's looking really nice. Let's give it a little twist now on each one of the individual hair tubes. We need to find a way that we won't have to loop over each one of these individual values, and we can do it using quaternions. Okay, let's create some twist on each individual tube. There are many ways to achieve this result. We could iterate over each ID packet of hair strands, but that will be a little time consuming. We need to do this on a really efficient computational way. That's why the best approach to create this twist is to modify the orient attribute. We are already orienting the copied points, and we can twist them along with the orientation. So let's return to our cubes, and I'm going to create a ramp to control the twist. Let's create this attribute wrangle, name it create twist, and let's start off to float. Let's call this twist, and let's take the UB value on X to create this twist. Then we can multiply this by 360, so we get 0 rotation here and 360 degrees of rotation right there. Now let's create a quaternion from this rotation value. A very nice thing about quaternions is that we can multiply them together and they will sum up. This way, if we start with a rotated quaternion on this side, we are going to multiply it by the orientation that we have already there, and everything will connect accordingly. It will be just like rotating this box on the z-axis without needing to do some copy stamping or calling attributes from each loop. So let's create a quaternion variable from this rotation. Let's create a vector 4 quaternion, and we are going to call this Qt, and let's use the Euler to quaternion formula. We just need we need a vector for this one. Let's create this. Let's call this Euler, and let's set it on 0, 0, and twist. Let's get this from Euler, and there's an error. There's an error. This Euler to quaternion formula is expecting a second entry. That's okay now. We have our quaternion. Now let's create the quaternion multiply for this twist. Let's get the orient and use quaternion multiply the orientation by the Qt quaternion that we just made, and we should have some twist here. It's just a lot of twist right now. That's because we are feeding these Euler values, and the function is expecting this to be on radians. So let's convert our Euler values to radians. And that should do it. We got a nice twist on the hair strands. Let's just check everything is working the way it should. Looks like that. And now let's just create a parameter here with a global multiplier. This way we can control the twist, giving it values even further down, like 2 times twisting for twist on the hair, or just like half twist without having to modify this ramp. We can modify this ramp just to give the overall twist on the sections, but let's do that later. Let's check out how this is going on the hairs. Here we are. Every individual hair tube has now some twist on it. It's looking really good. Okay, now for the final step, let's create some curls on this twisted geometry. Okay, so let's do some curling here. Let's simplify a bit this setup. We have too much going on right now on the screen. So let's get rid of almost all the hair. Let's just visualize here, deleting most of the primitives. So here we got the twist. It's looking good right now, and let's modify the profile that we are copying into the points of the primitive. So right now we are just twisting from the center of these scatter points. We have to get them off center. We can do this just with a transform and translate it a little bit to the left and scale them to get a nice flat shape. And there it is. When we add our points, they are twisting off center. They look like a ribbon. The further we do this, the bigger the curl will be. Now we could also transform these points so that they are facing the same way that the curve will be facing. Let's rotate them 90 degrees. And we are getting much nicer curl right now. Okay, let's up the twist value. Let's give it something like 4. And right now we lack the detail for the curls. We need to have a lot more of geometry. That's why we have this resample here. So let's create a lot more of detail so we can get those nice curls going. And now let's just visualize the whole system, and there it is, a lot of curls. It's looking really nice. We can get a lot more of twist going here. And this translation will tell Houdini how much are we going to curl this. So just to finish this, we have to combine both situations where we got the hairs on just like a pack and on a curl. So let's combine these two. Just to finish, we have to create a blend between the curly hair and the twisted hair. Alright, I'm going to get this transform on the end of the line because we are going to create another copy to points. And I'm going to connect this to the unchanged points. This way we can get the twisted hair and the curly hair right here. Let's just copy an attribute. Let's call the point position and let's rename it to rest. So we don't have to deal with too much branches on this. Okay, so we have now the rest attribute here. We can switch between each one of those by switching from curl to twist, but we have to do this on a controlled way. We are going to use a linear interpolation. So let's create a lerp between the position and our rest position. Let's give it a value of 0.5 right now, and this way we can blend between the twisted hair and the curly hair. Let's just create a ramp so we can control and fine-tuning this blending. Let's create a float, blend ramp. And let's use the UV value. We have a nice ramp here. And let's just change the 0.5 by our blend. This way we can control how much curling and how much twisting we have on the hair. Looks like it's reversed right here. Oh yeah, it's reversed. Let's just invert it, and there we are. We can control the base. Will most likely have no twisting, no curling, and the middle section will have just a lot of it, and then the tip section might be again without it. Okay, looks pretty good. Let's just name this. Set curl and change these to purple. So we can keep an eye on this. Okay, let's finish this by tweaking the values on this strand. Let's first of all give it a little less twisting on the base side. Let's search for create twist. We can control where the twist is starting. Let's change these two to B-splines. And let's give it a little less twist on the starting point here. Let's get this almost straight hair going there, and then just curling a lot more when we get those hairs a little bit of freedom. And then to the end we are not going to have that much of a twist. We can change this anytime we want with the global multiplier. Get a lot of twisting going there. And let's also change the overall width. When we have curls, the hair tubes should be a little wider. Let's get the hair width. It's just uniform right now. Let's change these to B-splines and make it smaller on the start and a lot bigger where the curls are. Okay, looking good. And just a little bit of global multiplier. There we go. Nice and curly. And Let's just rid of our delete. Now let's just not go too crazy with the curl. There we are. We have some nice curly hair. Let's create some color attributes just to finish this off. So let's create some color on this hair. Let's create a attribute wrangle, and let's create a vector type. Let's call this color, and this will be a let's create just a ramp called color based on the UVX vector that we are using. Let's specify this as a vector ramp so that we'll get color going here, and let's just assign this to the color. Okay, let's get some roots, little darker color. Let's saturate it a bit, and on the tip side we'll get a little bit brighter color. So we can also do some thinning before sending this to the color. Let's create a guide process. Let's just change it from set direction to set length. Let's multiply it for a random value from 0 to 1. This way we can randomize the length of every hair without getting too much weight on the system. It's looking really nice. Let's just give it some color variation. Let's do it with a float. Let's create a random function with the primitive number, and multiply this by our color. Let's just fit this onto nicer values like 0.9 and 1, so that we'll have not too much variation. Okay, here we go. Some nice curly hair. And well, this is fully procedural. We can fit the system any kind of geometry we like. The geometry has to be based on tubes and has to be properly laid on the UVs so that this will work. Let's change the base geometry here. Let's wait. And it's working. There are some connections going there. We have to adjust our line ID attribute. Let's get it another 0 there, and it's looking really nice. We can check out the third iteration of the hair, and we can get many art directable grooms going on here. Hope you like it.